This video will be a bit longer than the previous ones, as we are looking at a number of sheets that actually are talking to each other and build off previous work. So we'll step through this. This will again take a bit longer, as I've just said. Again, we're going to be looking at duration, cost estimate, optimization, critical path, crash duration, and crash cost estimation. So let's just step through each of these and see how the different material actually link together. In many ways, this group of slides is somewhat similar to the exercise that we did in class, where we move through these different sorts of elements. So let's just, now that we've got a quick overview, we can actually see the Excel sheet sitting over here. The layout is all fairly logical. We can see that this part of the file is simply what we've done previously in terms of the predecessor. We now find that we have got additional information actually moved in, which is the Slack information. This is actually taken from Microsoft project and is pasted back. Again, let's look at each of these in a bit of detail. So again, the green tells us it's in Microsoft project coming across. All these estimates are things that we've done previously, so we're aware of these estimates going up, and we can actually see that we've got all the calculations sitting at the top. Again, we'll zoom out a bit, make it a bit easier. We've got these Slack estimates. These are actually taken off Microsoft project, and we have our critical path. Always we need to be a little bit careful when we're talking about slacks, because we can have 0 slack, but we may be having, that doesn't mean they're all on one critical path. It can mean they're on a couple different critical paths and all have 0 slack. So you just need to look at that in Excel and make sure that you've checked that aspect of it. Again, looking at the top, critical path, alternate critical path. Again, alternate critical paths are somewhat confusing, but basically a good way to think about alternate critical paths is that we've looked at what's the amount of slack, and if our pessimistic time estimate was to come into play, whether there would be any slack available. In other words, it's very similar to looking at 3 times the variance, so it's pretty much the same sort of logic. So we just want you to be able to demonstrate that. If you haven't got that in your figures, then you need to sort of have a bit of a play with your time estimates to get something which sounds plausible. Again, in this exercise, what we're actually doing is you're trying to demonstrate that you know how to deal with these sorts of issues. So part of it is making sure that you construct your data in a way that allows you to actually reveal that you know how to deal with this. So you can see a number of a bit of analysis is done here, linking back to the alternate critical paths. Now, here we've got the different path numbers, and they again link back to the task ID numbers. You find that of course the task ID numbers will not be identical to the cell reference numbers, so you've just got to be a little bit careful about the difference between these two. Over here we can actually see that they've done a sum of the cell references. Again, it's always worth doing a quick check that you know you're just adding different numbers. Now we look at the second lot. Again, we can see what they've done there with their alternate path, etc. Now, to create the crystal ball, what they've done is they've looked at these alternate paths. We know this is most likely it's going to be the one, but we're not too sure. So we run all simultaneously by using a max function, which means we go back and we check all those, and we can then determine which one is the longest. So that's neatly done. And then we generate the crystal ball graph. Now let's just go out on this for a second, and we've clearly got here the 95th percentile. So again, just scrolling out and moving across so we can see that. So we now knowing that we've got our 95th percentile is going to be, and clearly labelled, which is well done. 90% certainty will be completed in 136 days. If we look at the duration, we simply go back to here as we would expect. We look at 127 days, which is roughly here, and if we want to put 127 days in, it would come back to somewhere pretty close to 50% in terms of the duration. So let's look at how this links back into the other slides. So looking at cost estimation, and again we'll scroll out and get the overall logic of this sort of stuff. We'll scroll to the side, let's go out a bit larger. No neat way to get this onto a page. So let's just look at each of the parts. We've got direct labour costs. It's good to get this down. So all the direct labour costs is again similar to what the resources that we've placed into Crystal Ball. We probably should have, we'll jump back to that. We'll have all our different resource rates for all our different sorts of people, and then these are actually calculated out. Again, going across, we can see that we have again our expected value. These is very similar logic to what we do with the time estimates, but we've actually got that linked into the cost estimates linked to the different sorts of people. So this is our direct labour cost. Now, if we go back earlier, we actually find that we've got a sheet, which is the resources sheet, which I didn't get to the bottom of this because I was looking at the top half of it, but underneath we have our dollar amounts. Let's have a look at that in terms of costs. I think it's down below. I'm just getting a bit of help with this one. Yeah, so that's fine. It just sometimes takes a while to actually see what's on the sheet, and that's why these sorts of headings are useful. So now we've got our costs for our project officers, judges, quality testers, etc. So that looks okay. Nice bit of logic there. Going on to the others, we have got our indirect costs. Now, occasionally people get indirect costs confused, and they link it to all the different times of each of the deliverables and add it together. And again, it's sort of an easy step to make, but in reality we've just actually calculated what we believe to be the duration of the project, so simply the duration of the project by the indirect costs. In practice, we try to get our indirect costs, which links somewhat to our crash costs, so that we can actually show what is the optimization point. We'll talk about that in a couple of slides. So now we've got our indirect costs based on $400 a day. Indirect simply means it can't be clearly allocated to any activity in the project. Often it's rent of office space, other administrative charges, etc. So now let's move on to before we do that, I'll go down below, because again there's a lot of information on this sheet, and we've got some other costs involved. We have got, in this case, we've got the contractor, so they've actually used a contractor. And the contractor cost will of course be, the contractor has to make a profit, but that will involve all the direct labour costs associated with the activity and all the direct consumables associated with that activity, and the contractor is saying we can get all this done for this amount. And if it's somewhat equivalent to what you would do internally or even cheaper, then of course it makes sense, but often we use a contractor because they have other advantages in terms of time or other capabilities. And sometimes we link in direct consumable costs, which are different than the labour costs. Again, the analogy is pretty straightforward. You're building a wall, it may take longer, but the amount of bricks you're going to be using to build the wall will be different. However, there can be some variation in the consumables in terms of how much the components will cost, and so therefore 1,000 bricks might move from being 500 to 800 to $1,200. So again, just a bit of logic there is always useful. What we might do is we'll create a break here and we'll move into the next stages, which is the optimization, the critical path, and the crash duration, and the crashed estimation. And we'll use that as a way of drawing this material together in the final video.